Imagine looking up at the night sky, and knowing that one of those tiny stars has a planet just like Earth. Not just any planet but one with oceans, breathable air, maybe even life. Sounds like science fiction, right? But it's not. Scientists are closer than ever to finding another Earth, and what they've discovered so far will blow your mind. From distant exoplanets orbiting red dwarfs to new technologies that analyze alien atmospheres, we are now entering a new era of space exploration. In this video, we'll explore how close we really are to finding a second Earth. What have we discovered so far? What tools are we using? And what would it actually mean for the future of humanity? From the moment humans first looked up at the stars, we've been captivated by the night sky. The ancient Greeks believed in celestial spheres. Ancient Egyptians charted the stars for agricultural seasons. And thousands of years ago, people were already dreaming of other worlds. Then came Galileo in the early 1600s. With a telescope no bigger than a pirate spyglass, he discovered moons orbiting Jupiter. That moment shattered a long-held belief, that everything revolved around Earth. If Jupiter had moons, what else was out there? Later, science fiction fueled our imagination. Stories like The War of the Worlds and Star Trek didn't just entertain, they planted seeds. What if there were other Earths? Other civilizations? Could we ever get there? But today, it's no longer just fiction. Scientists across the globe are hunting for real, Earth-like planets.
Searching for life elsewhere is one of the key themes that drive our science portfolio.
Not just any planets, but ones where we might one day live, or where someone, or something, might already be living. Finding another Earth sounds impossible. After all, we're talking about spotting a planet dozens or even hundreds of light years away. But astronomers have developed clever techniques. The most successful method? The transit method. Picture this, you're watching a distant star. If a planet passes, or transits, in front of it, the star's light dims ever so slightly. That tiny dip tells us something is there. It's like trying to notice when a gnat flies across a car's headlight from 100 miles away. Sounds crazy, but it works. NASA's Kepler Space Telescope, launched in 2009, revolutionized this technique.
0 and liftoff of the Delta II rocket with Kepler, on a search for planets in some way like our own.
Over its mission, it detected over 2,600 confirmed planets, many of them rocky, Earth-sized, and sitting in their star's habitable zone. That's the sweet spot, not too hot, not too cold, where liquid water could exist.
Planet E orbits within the star's optimistic habitable zone. These are distances from the star where liquid water could exist under the right conditions.
Today, its successor, TESS, transiting exoplanet survey satellite, scans almost the entire sky, focusing on closer and brighter stars. The goal, find planets that are not just out there, but within reach of further study. So what have we found? Let's start with Kepler 452b, often called Earth's cousin. It orbits a star very similar to our Sun, and it's just 60% larger than Earth. It's in the habitable zone and could have oceans, clouds, and maybe even continents. Then there's Proxima Centauri b, orbiting the closest star to our own, just 4.2 light-years away. It's likely rocky and sits in the habitable zone. But it orbits a red dwarf star, which flares frequently. That could strip away its atmosphere, making life difficult, but not impossible. Perhaps the most intriguing? The TRAPPIST-1 system.
I looked at the data myself, I'm like, yeah, there they all are. It's just, I would have never predicted this. It's beyond, anything I could have ever dreamt of.
Just 39 light-years away, it has 7 rocky planets, all Earth-sized, and 3 are in the habitable zone.
The big news is that around a very nearby, cold, small star, we found 7 rocky, Earth-sized planets, all of which could potentially have liquid water.
Imagine 7 Earths orbiting one star. But here's the twist, Many of these planets might be tidally locked, meaning one side always faces their star while the other is in permanent darkness. It sounds extreme, but even in such conditions, life could find a way, maybe in a twilight band, a narrow ring of life between night and day. The launch of the James Webb Space Telescope changed everything.
From a tropical rainforest to the edge of time itself, James Webb begins a voyage back to the birth of the universe.
2006.
I've been working on it for 20 years.
For 13 years.
There are people that have literally spent their careers working on this telescope, their entire careers.
Unlike previous telescopes, Webb sees in infrared, letting it detect the heat signatures of distant worlds. It can peer through cosmic dust, glimpse the formation of galaxies, and most importantly, analyze the atmospheres of exoplanets. How? When a planet transits its star, some of the starlight filters through its atmosphere. Webb splits that light like a prism and identifies what's in it: water vapor, carbon dioxide, methane, even ozone. Each of those molecules is a potential biosignature, a sign that life, or the conditions for it, exist. Webb's early results are already promising. It detected carbon dioxide on an exoplanet for the first time. Soon, we may find water vapor. Or more. And future missions, like LUVOIR and HabEx, will go even further, aiming to directly image exoplanets. Imagine seeing a distant Earth not as a dot, but as a real world, with continents, clouds, and seasons. But wait. Just being in the habitable zone isn't enough. A true Earth-like planet needs more: a breathable atmosphere, a magnetic field to block solar radiation, plate tectonics for climate regulation, a stable orbit, possibly even a large moon, like ours, to stabilize its tilt and seasons. Earth's magnetic field, for example, protects us from solar wind. Without it, our atmosphere would be stripped away, like what happened on Mars. Our moon plays a crucial role too. Without it, Earth's tilt could wobble chaotically, causing climate swings that might make life unstable. So when we say Earth-like, we don't just mean the size or orbit. We mean everything that makes life, and complex life, possible. So what comes next? One bold idea is Breakthrough Starshot, a mission that aims to send tiny spacecraft the size of a postage stamp to Alpha Centauri using powerful Earth-based lasers. These light sails could travel at 20% the speed of light, reaching the system in just 20 years. These tiny probes won't carry people, but they could send back pictures and data from planets like Proxima b. NASA and other agencies are also planning more advanced telescopes that could image exoplanets directly, showing us weather systems, surface features, even signs of cities or artificial light, if they exist. It's a race between technology, curiosity, and imagination. Of course, the biggest question is, are we alone? We haven't found alien life yet, but the silence might not mean we're alone. It might mean we haven't looked in the right place, or with the right tools. Some scientists focus on biosignatures, looking for life's chemical footprints. Others look for technosignatures, like radio waves, artificial lights, or planetary-scale pollution. If another civilization is out there, we might spot them not by their biology, but by their technology. But what would that discovery mean? Imagine NASA holds a press conference. They confirm an Earth-sized planet with an atmosphere like ours, and methane that fluctuates seasonally, just like it does here. The implications would ripple through science, religion, philosophy, and even politics. Finding life, any life, would prove we're not alone. Finding intelligent life would prove we're not unique. So, how close are we to finding another Earth? Closer than ever. But maybe the more we search, the more we realize just how rare and precious our own planet is. Because in our quest to find another Earth, we may end up rediscovering the wonder of the one we already have. The stars may be infinite. The Earth is not. And the search continues.